everybody, and thank you for taking time today to join us for our fixed wireless access network design webinar. Today, Brian's going to walk us through configuring 5G systems using our automatic site selection tools and going through the entire lifecycle system, including introducing and showing off SignalPro's new feature set for BDC filings. And throughout this process, if there are any questions towards your screen, there should be an area that you can access and submit questions into us, and we'll take some time towards the end to answer any questions that come in. So feel free to send those if you come across anything while we go through this process. So without any further delay, let's jump over to Brian to get started.
Hey, thanks, Rory. Can you hear me okay?
Yes, absolutely.
Great. So thank you, everybody, for joining today. Today's presentation, like Rory said, is going to sort of track the entire life cycle of an FWA network, or sort of talk through the life cycle of an FWA network from the initial greenfield planning stages to actual deployment, and then finally these new BDC filings, and look at how SignalPro can help you along every step of the way. And I've got some slides here to show you, but I'm also going to be jumping to the SignalPro software because I see there's a lot of current SignalPro users that are working with this technology today here in the audience. So I'll try and give you, more than just a sales pitch, but something sort of useful to take away from the software. So the first thing to talk about is, FWA, fixed wireless access, can mean a lot of different things. It can mean a lot of different frequency bands, most of them higher frequency bands, obviously, to get more bandwidth, but it can also mean a variety of different technologies which can have different performance criteria associated with them and need to be planned for a little bit differently. And of course, if you've got just SignalPro, sort of the core package, you can do analysis for any frequency band. So in those initial greenfield deployment stages, maybe if you're evaluating different frequency bands where that you might be able to leverage, of course, you can do that with just SignalPro and look at sort of pure coverage and path loss based assessments of your candidate sites and that sort of thing. But when it gets into the deeper planning, the network design modules that we offer expand the support for those specific technologies so that, for example, if you've currently got maybe an older WiMAX or Cambium or Wi-Fi system that's providing some broadband coverage to fixed assets, you can look at all of that using our WiMAX module, and that basically covers any OFDMA technology like WiMAX, Wi-Fi, Cambium, other proprietary and custom solutions, and also international solutions like WiBro are all covered under this WiMAX module. And then LTE, of course, is current and previous releases of 4G LTE. And then our new 5G module is very, very similar in feature set to the LTE module, but it expands the feature set for 5G so that you can handle the very high data rates, and there are some specialized studies there. And the other thing that you get with any of those network design modules are a set of tools for either like automatic channel planning or PCI code planning in the case of LTE and 5G, neighbor lists, all that sort of thing. And the one that I'm going to talk about a lot today is automatic site selection. And so let me just jump to the software real quick. and kind of give you a quick overview of my little example project here. I took just a small area in the Portola Valley that's mostly residential, and just for a hypothetical network to work with, I defined this polygon area to say, okay, I'm going to deliver broadband in kind of this neighborhood, and I created a list of candidate tower and pole sites that I could leverage. So these light blue triangles here would represent the locations that I might place an E node B in the case of an LTE system or a base station of some kind. And the way I got this tower list into the software here, that layer that we're showing there, that's under databases, towers, and poles. And if you haven't used this tower and poles database yet, you can see we have functions for importing them from a list of KML points from Google Earth or just from a CSV list. And one of the cool things about this pole database is you can have a huge number of candidate sites in the pole database that you do not have to create in the project. And, you know, anybody who's ever tried to create 1,000 sites in their project knows that the GUI will start to drag and the project size gets very large. This pole database, you can have a huge number of poles in the file, and because it's just a nice lightweight CSV file, nothing's gonna drag or, you know, move slowly in your software, but we can still evaluate all of those pole candidates based on their location, their height, and if you enter that data, there's also a relative cost value. So we can be looking at the differences in deploying on a site that already has fiber to it versus a site that would need to be made ready before it could be utilized. So, you know, those differences in the cost of deploying on the poles can be included in this as well. And that's something we don't see a lot of people using yet, but we have had some good success stories from the folks who've tried this out and used the automated router selection with costing associated on their poles. You can get a very efficient selection of base stations by using that cost value there. So when I talk about the automatic site selection tools, in this example, I have all these candidate towers and I have this polygon for the area I'm trying to serve. And maybe in the initial greenfield stage of the design, I don't know where the fixed subscribers are going to be yet. I just have a customer saying, hey, we'd like you to deliver broadband to this area. And so I can set up my automatic site selection. You know, of course, I set up the project first with geodata. Here I'm using our Cirrus subscription clutter data and terrain. And I set up my propagation model and set up a typical base station template, all that. And then I can go into this network design analysis. And again, this is if you have one of these network design modules for 5G or LTE or WiMAX or LoRa, then you'll also have these auto placement options here. And this is the auto placement for areas is going to take the study grid or the you know, if I run an area coverage study like this, I've constrained it into the polygon, and each one of the little pixels within this this map becomes sort of a point to be served by the towers that are being selected. And so if I go in here to auto placement for areas, I can set up what propagation rules I want to use, set up the router candidates I want to use, and I've picked my pole database here. And then if I'm working with an area grid, it's possible that the grid represents so many points to be served that I want to sort of sample that down. And you can see here I've got 1.3 million points within my study grid, and it's going to address each of those as like a potential client to be served. And so I want to sample that down just to make it run faster. So I put a 4 in here. So in other words, it's going to, for every 4 grid points, it'll collapse that into 1 sample point just for the purposes of that site selection. And that gets me down to something on the order of 81,000 points. And as a guideline in setting this up, I do recommend you try to get that sample size to something less than 100,000, at least in the first pass, because additional resolution right at the router selection or the site selection stage, it's kind of a diminishing returns effect. You don't get a much better site selection by dealing with everything at a very, very fine point spacing. So by sampling this down, I can just make it run faster. And down here, this is my service area boundary polygon. So this is this blue area boundary that I'm trying to serve. And so I've set up my prop model, my candidates, and the area I'm trying to serve, which is those grid cells that are within this polygon. And when I go run auto placement calculation here, you can see I've got 4 different methods that I can choose from. I give it a group name, choose the template for the sites that I want to create, maximum range, and the target power threshold, or the effective sensitivity that I want to target for site placement. And you can see this is really high. And that's because I was trying to get a high RSRP and create sort of a lot of cells to serve a high data rate to my whole area. And I worked backwards from the desired RSRP that I wanted in order to get to this threshold. A quick word on these methods. Method 1 here is just going to try and keep adding sites until it reaches whatever percent coverage you've put here. So it just looks purely at coverage and tries to get you an efficient selection to just cover the area. The capacity and coverage method here, this you might use more when you're treating the selection as a multi-point selection, which we'll look at that in a moment. But here I put in the maximum number of sample points, or grid cells, in other words, that one site should be able to serve. And this will try to cover the percentage of the area that you target, this percentage here, but it will also be sensitive to making sure it's placing enough sites to serve the capacity. And when we do have our subscriber locations and want to look at the multi-point network itself, it can be good to run this capacity limited selection to see if you need to add additional sites to serve those subscribers that are already there. The really fancy method is this method 4, capacity planning with local greed. Oh, whoops, I need a new group name. So capacity planning with local greed. And the main thing to know about this one is that this is the automatic selection method that can look at cost as well. If you do have different relative site costs for those pole or tower locations, this method 4 can take advantage of that. And we set threshold values and we set the maximum capacity, which in this case, I just kind of set a really high number because I wasn't worried about capacity. And here's my percent coverage over on the right. And if I turn this on and I have different costs for my different sites, I've basically got an adjustment bar, which is an easy way to adjust having more sites or fewer sites without having to wrap your head totally around the capacity per cost ratio that we're looking at here. And that costing is worthy of a whole webinar training all by itself. But the nice thing about having this slider bar is you can just quickly adjust the solution without going to your calculator and trying to figure out, wait, how many subscribers per tower unit cost do I really want to have? So that's, it's a little easier now that we've got that slider in there. And when I run this, and I won't run it now because we don't need to watch the progress bar cook, but when I run this, it'll go through and evaluate the coverage of all those candidate sites and look for a solution and present that to me, and then allow me to interact with that solution and add or remove sites if I want to, so that, maybe I see an area that I really want to make sure is covered, or I see a site that I know I want to use, so I can switch that on and maybe switch another one off, or that kind of thing. So it provides you an automatic solution that you can then tinker with. And that's how I got to this group of transmitter sites here. Let me just switch my slides here to make sure I'm not forgetting anything. Yeah, okay, so this is just what we were talking about. We can look at candidate sites based on the coverage footprint and their relative cost. And that proposed site list that we give you is interactive, so that you can immediately see what would happen if you turn off this site and add that site, that kind of thing. And so once I had this greenfield sort of site solution, at that stage, if I'm still sort of in the bidding or pre-deployment stage where I don't have my subscriber locations, then maybe I just run area coverage predictions. And so what I've done here is I've gone into area studies, and I've added, in this case, since I'm using a 5G technology, I've set up my 5G studies for RSRP and downlink and uplink throughput. And of course, I've set that up under the 5G networks. I've set up my details as far as the technology profile I'm using, the frequency band, all of that. And here again, any one of these modules is kind of worthy of a training in and of itself. But if you haven't looked at the LTE Pro or the 5G feature set in the latest version of the software, what I'd first want to direct your attention to is, yeah, okay, you can set up your technology profiles and stuff in these dialogues. But once you've done that, or if you want to do it in an alternative way, this RAN import feature allows you to use a spreadsheet format to work with all this data. So if I open my RAN node workbook for this project, I'm going to take just a second for Excel to open here. So here we've got, let me expand this out. There we go. Here we've got the technology templates I'm working with, the CQI tables that these are configured per the standard by default, but if you're doing a custom solution where some mod types aren't enabled or something like that, you can change all of this stuff up. And here's my slot configuration for the frame. So if I've got, more slots on the downlink than the uplink in this case, because I'm trying to deliver a higher data rate down. And the nice thing about all this is I can set up those technologies and everything and save that and make it, port that from one project to another using that spreadsheet. So sort of once I've set this up, I can use it as the basis for other projects as well. And if you've got different bands, different technologies within the same project, the important thing to make sure is that you just go in and list which sectors are using which technology, and then that'll all be correctly interpreted by the software as it's figuring out its data rates and RSRP, RSRQ, all that stuff. And so in this case, what I've got is 3 sectored sites. I think this is the N 66 band, 2.2 gigahertz. And you can see I've put a MIMO, an 8x8 MIMO antenna on all of the sectors as well. It's important to make that MIMO selection, especially with a lot of the newer products out there that are all leveraging MIMO, that can have a real impact on the data rate. So you want to make sure and select that there. And if they have something that's custom, you know, if the product you're working with has a funny MIMO or SDMA setup, you've got some user-defined categories down here under your MIMO adaptive antennas, so you can set up the performance of those as well. So I do my RSRP map here, and more importantly, my downlink and uplink throughput. And you can see anything in this dark green here is 6,400 megabits per second, I guess 6 gigs, versus, you know, going all the way down to less than 100 megabits per second. And then I've got the same on the uplink, which those are slightly different values here. Let me make it so you can see those. Yeah, so here, anything above 750 megabits per second is in the dark green here. And so you can see I'm getting a much higher data rate on the downlink than the uplink. And I can then take those studies and, for example, I can query against them to be able to tell the potential customer or what have you. Oops, went to the wrong dialogue. I could tell my customer, for example, you know, within the Portola boundary, how much of the area is covered within these threshold values, or how much of the area is at the data rates we want. So I'll run that query there. And you can see I've got 72% at that highest data rate and about 27% down at the lower data rate, which is, you know, I didn't set up my site selection to try and make the entire area at this data rate, because that would have included a much larger number of sites. So this was kind of the middle ground I arrived at. And I can, of course, export this information as part of my reporting or RFP or that kind of thing. And now at this point, so here's my coverage and performance predictions. And you can see in this picture, I've got both area studies and point to multi-point studies represented. And so maybe it's at this stage, we win the bid, we're building out this network, and now we've got a list of customer locations, which I go ahead and, you know, set up as CPE data. I go ahead and import all of those. In my case, I gave myself 200 subscriber locations here, and I imported those using the CSV import in the spreadsheet editor. And so that's my CPE customer terminal layer here. Here are all the devices that I want to serve. And now maybe I look at this site selection and I want to see if I can do a little bit better. Under the multi-point backhaul networks option here in network design, you've got create hub transmitter group that gives you, if I go to automated router selection here, this gives you the same sort of options I had in the area auto placement method. I set up my prop model, my candidates, and if I have a large number of CPEs, I can reduce them, but I don't actually need to because I've only got 200. And now here I've got those same methods. And if I run it from here, it's not going to try and serve the whole area. It's only going to try and serve those fixed subscriber locations. So in principle, if I ran this, I would get fewer sites than I have serving the whole area. But of course, you know, maybe in this network, I want to add more subscribers than just this. So I'm going to stay with the site selection I have. And now that I've got my CPEs into the project, I can go into multi-point studies and set up all of those same study types. I've got RSRP, RSRQ, downlink and uplink throughput, signal over noise ratio. And there's another group that I wanted to point out here. You see this one that's called minimum CPE antenna height for LOS, or line of sight. So if I go to add a multi-point study here and look at the multi-point study group, this is one that only appears in the multi-point studies, and you'll only have this group if you're using one of the network design modules, but this has some specialized studies that are really handy for fixed network design. The minimum CPE antenna height, this one here, does just what it sounds like. It tries to see how high up in the air that subscriber would need to be in order to have line of sight to the base station. And you can set that up to be line of sight above just the terrain, or line of sight above the terrain and the clutter. So especially if you were looking at something like high band 5G millimeter wave design, for one thing, you'd want to have a very accurate model of the clutter heights. And for another thing, this minimum CPE antenna height would tell you exactly how high the mast would need to be in order to see the E-node B directly. Then we've got things like Fresnel zone clearance, total interference at the base receiver, uplink availability. This one's nice. You can set a base, a threshold on the uplink and the downlink essentially, and it'll just show you a pass-fail for each of the CPEs. So I just wanted to point out that multi-point study group because in talking with people, I found that people are surprised to learn that minimum CPE height study exists, and it can be really useful, especially if you have options in how you're mounting those subscriber devices. So once I've run those multi-point studies, of course, I get my multi-point study layers here, and if I want to see my downlink throughput, I can do that. And if I add this CPE to hub links layer into my map, I can show those link lines. And what I've done is set this up to use the current study result color. So the link lines are drawn with whatever I set as the current study here. And I can see, which site each CPE is talking back to, and then I can drill down if I want to into the results for a particular CPE and, see all of the calculated results for that and do a path profile if I want, that sort of thing. So this guy's line of sight back to the base station and is going to do great. At this point, once I've run all those multi-point studies, and if I want to report those values out, I can go into study queries again. And if I go to multi-point study here, for example, maybe I want to look at my antenna heights, I can run that query. And this is great because for every CPE you get in this report here, its location, the calculated result from the study, as well as the azimuth, elevation, and distance back to the server. So I can export that as a table as well. I can look at the distribution of the different results, all that kind of thing. Am I forgetting anything there? Okay. Okay, so let's talk again about the site selection. At this point, sort of in my hypothetical life cycle of the network, I've got a network built out. I've got subscribers working. Sites are deployed. So I want to add, let's say I'm adding a new neighborhood, or I need to densify the network and add more sites to handle the capacity of subscribers that I'm starting to add in. I'm going to use the multi-point site selection here. If I go to create hub transmitter group, automated router selection, and I'm going to go into run auto placement here. And the feature set that I've talked with a lot of people about lately is this use installed routers in selection process here. So when I ran this automatic router placement the first time, I was just using the tower and pole database as my candidates, and I sort of created a new group out of whole cloth. Now that I have sites actually deployed in the field, I don't want to move those or get rid of any of them. So I want the new selection to take into account those sites that are already out there and only add sites that would expand the network into the area I need or add the capacity I need. And so in order to do that, I would check on this use installed routers. And if I have some active and some inactive, maybe I turn the use only active feature on, but in my case, I just leave everything active all the time usually. And so I'll choose that site group that I created, Auto Router 2, and that's all these sites that are already here in my project. And it's saying, okay, since I've got this checked on, it will consider that all of these sites already exist. And maybe I call this densification. My new group is going to include, so I'll say include installed as members of group output. So this new group called densification is going to include everything in Auto Router 2 plus additional sites to serve my capacity or whatever. Let's say all of my subscribers subscribe to an insanely high data rate and I can only support 10 subscribers per eNode B. I could run my capacity limited selection here, and it's going to try and add more candidates to the existing sites to try and support that new capacity limit on the devices. And again, I could do the same thing if I'm expanding, adding a new neighborhood, new area to an existing network, that sort of thing. So I don't necessarily need to go through and evaluate each potential site addition individually, or try and cut out the area that I'm adding to and just deal with it independently. I can just go ahead and use this installed routers and selection process, and it'll respect those network assets that are already there and add to my solution based on, whatever method I choose here. I can do that cost sensitive selection, or I can just look for the additional capacity alone. We kind of talked about the multi-point studies and reporting. Of course, I can run my queries. I can export those to Google Earth KMZ or a CSV spreadsheet. And now let's get into the new feature that's sort of the new and exciting thing today, in my point of view, from my point of view anyway. The FCC has started this requirement for showing your coverage area with a pretty specific set of criteria for what's considered covered. And there's a really handy dandy document here that's available at the help.bdc.fcc.gov. You can get this PDF here that defines what it is that you have to give the FCC as part of this filing. And, there's a few different technology codes for the different technologies that are supported. And long story short, when we drill down into this, one of the things that they want to see is a study or a coverage footprint of your network in an area study basis that gives a just pass-fail coverage. So I'll go ahead and show my study result here. So this is my BDC filing study. There we go. And basically, all of the green area is area that I can consider to be covered. And what this takes into account, if I go into area studies here, the way that we set up this study is to go into add study. And this is actually in the basic study group, because it doesn't just apply to only one technology, but it applies to several different technologies or system types. So we couldn't put it under 5G because it's also WiMAX and LTE, and it can, we can do a mix of technologies. So under basic studies, we've got this one here all the way down at the bottom called cell edge coverage. And as soon as I choose that, this button here for BDC filing settings is going to pop up. And what the study looks at is the data rate thresholds, and there's, depending on the technology that you're using, the FCC has different minimum requirements for what you considered covered. It might be 5 and 1, or it might be 7 and 1, or they're pretty low numbers, frankly. And then also there is an RSRP or RSSI threshold. Depending on the technology, the minimum threshold is either in RSRP or it's in RSSI. So in other words, just one subcarrier or the whole channel receive power. And here, let me go back to the one I already have set up here. I want to look at these settings here. So yeah, I've got this one set up the way it's supposed to be. And what it's doing for each grid cell, given the loading value that you have set up and the threshold values you have set up here, it subjects each grid cell to fading according to the cell edge probability and the standard deviation that you have here. And so you're going to see that, if you were just to run a regular received power map, the coverage you see based on RSSI or RSRP here is a faded sort of coverage. It's a 90% probability coverage. And so it looks at both the received power at each grid cell and the uplink and downlink data rates as calculated by the appropriate technology study. So if it's LTE sites, it's going to use the LTE data rates study. If it's 5G, it's going to use the 5G data rate study. And if it's WiMAX or Wi-Fi or what have you, it'll use those studies to come up with the megabits per second. And it puts all of that together into one area study result that's just a grid that shows where you have coverage. And I would take this and export it to, whatever my export format's going to be, probably shape Esri. You're allowed to submit it a couple different ways. So depending on your GIS platform that you choose, maybe you'll do it MapInfo or shape. But so that area coverage is the key thing that the FCC wants you to submit, along with a description of, they've got some fields to fill out as far as how you've set up your propagation model and what type of clutter data you're using and that kind of thing. And so it's kind of just a form you fill out to give the details of how you ran your propagation analysis, how you validated those propagation rules, and then this cell edge coverage map that you need to submit to them. And again, it's really easy to set up as long as you've already set up your system type and you can run data rate studies and you can run your RSRP study. Then all you need to do is go in, add study, and from the basic group, it's this cell edge coverage down at the very bottom. And then make sure that you set these numbers up properly for the technology code that you're working with, based, again, based on this FCC document. Where's that list? I think it's basically 300, 400, and 500 are the technology codes. Oh, I'm not going to be able to find it quickly here, but so yeah, all of these fields are fields that you have to fill out in reporting to the FCC, and then then you also have to include the GIS information. And again, you can get that from this help.bdc.fcc. So this latest feature set is something that we sort of prioritized getting into the tool as soon as the rules and recommendations were available. And we've created that study based on the FCC requirement. And we've done a bunch of testing on this and confirmed that it's reporting the way it needs to based on this. We'd love to hear feedback as folks are doing these BDC filings, if there is any feedback either from the FCC or just as you're working through the process, as you're exporting this data and, reporting the information you need. We're happy to work with you if you're not sure how to answer some of the questions that they're asking for, like the questions about propagation model, how it was validated, et cetera. That's stuff I can help you talk through if you wanted to book a customer success session and talk about that. Or of course, you can always go ahead and start a support ticket on edx.com through the customer portal. So those are the features that I wanted to sort of talk through today. And this, really the takeaway story that I want you to see is that, SignalPro, the core tool, sort of has the basic tools you'd need for that initial greenfield assessment potentially. But then by adding on the network design module for LTE or 5G or what have you, you can get all the way to deploying the network, optimizing the network for the number of subscribers you have, densifying, adding additional sites, and then finally doing these BDC filing studies, which are going to be a recurring thing that you'll need to submit. I forget I think it's biannually, but don't quote me on that. Look at the rules. So at this point, we'd be looking at sort of an operating network that maybe I'm expanding and adding as I go, and then refreshing this BDC study every time I have to turn around and file again. And I'd like to open it up to questions now. If anybody has any questions, go ahead and type those. There should be a Q&A section in your GUI there. Go ahead and type that in there, or you can use the chat window if needed. And Rory, let me know if any of those come in. I'm not sure I can see that window without hiding other stuff.
Yeah, I haven't seen anything come in for the general audience. Anything specific has been answered individually, but there's nothing yet. Just wanted to give a minute to see if anyone had any questions.
Sure. I know I talk pretty fast, so. Okay, well, again, thanks everybody for joining today. If there aren't any additional questions, feel free to reach out to us when you are getting into working with these studies or working with your own networks. Again, I'm happy to set up a customer success session for anybody who's working with this stuff to kind of, talk through it in a little bit more detail and hear about what you're doing and how things are going. So do feel free to reach out to us. And I think that's pretty much all that I had for today.
Yeah, thanks, Brian. Just wanted to say thanks to everyone for joining, and we'll see you in the next one.
Yep. Thank you, everyone.